I am Anil Kumar. In this video, we will learn how to find distance from a point to a line. Now, I've taken two examples where the equation of line is given in vector form. Now, at times it becomes difficult for students to find the distance when equation of line is given in vector form. Question number 1. Determine the distance between the origin and the line r 1 4 plus s times minus 1 2, where s belongs to real numbers. So that is in R2. Question number 2. Determine the distance between the point 6 3 4 and the line r equals to 0 1 3 plus s 2 minus 1 minus 2, where s belongs to real numbers. So that is in R3. So let's take up these questions one by one. So let me solve question number 1 here first. We are given equation of the line, which is r equals to 1 4 plus s times minus 1 2, where s belongs to real numbers. Now the idea here is to convert this equation to Cartesian form. So that is the strategy, right? So you should convert this to Cartesian form. Then you can directly use the formula. Formula will be distance is equal to, say, ax0 plus by0 plus c divided by square root of a, the magnitude, right? A square plus b square square root, the magnitude of the normal vector. Perfect. The idea is we have to find the unit vector in the direction of normal. Now you could write this equation in Cartesian form in different ways. The best way is, we know that the direction is in R2 given as minus 1 2. So what should be the normal from here? So this implies that the normal should be, swap them, so we get 2, and change one of the signs. So we'll make negative 1 as positive 1. So that becomes the normal. And therefore, we can write the equation in Cartesian form as 2x plus y plus c equals to 0, right? So that becomes the equation of our line. Is it okay? Now to find the value of c, we can use the point given on the line, which is 1 4, right? So we do have a point. Let's call this as p0 as 1 4. Substituting 1 for x, 4 for y gives us the value of c. So we get 2 times 1 plus 4 plus c equals to 0, which is 6, right? So this gives you the value of c as minus 6. So therefore, the equation of the line can now be written as 2x plus y minus 6 equal to 0. So what we have done here is written the equation in Cartesian form. So this is what is the first step. So we have Cartesian form of the equation. Now it is easy to find the distance, right? The point given to us is origin, right? So when we say distance from origin, we want to find distance from origin. Which is 0 0. So in this formula, we'll substitute 0 0 for x and y. So we get distance d as equal to absolute value of a is 2. So 2 times 0 plus 1 times 0 minus 6. Distance is always positive. Square root of 2 square plus 1 square. So that gives you 6 over square root of plus 1 as 5. It is always a good idea to write the answer with rationalized. So we have 6 times square root of 5 over 5 as the distance in this particular case, right? So that becomes the answer for part A. Now let us see how to do the second part, where the equation is given in vector form and we are working in R3 space. Question number 2. Determine distance between the point 634 and the line R. So let me write down the equation of the line R as 0, 1, 3 plus s times 2 minus 1 minus 2. We are given the point as, let me call this point as Q, as 6, 3, 4. Now, first step is to find the direction for normal, right? So that is the first step. So we have to get normal first. So what we can consider here is, we know the point Q, which is 6, 3, 4. Original point is, we can call this point 0, 1, 3 is a point given on the line. Q is 6, 3, 4. So from here we can get the vector PQ, right? So from here we could get the vector PQ. So PQ will be 6 minus 0, which is 6, 3 minus 1, which is 2, and 4 minus 3, which is 1. So that becomes PQ vector. Now, to get the normal, we have one direction PQ, the other direction is given to us. So, for getting normal, we will do PQ cross the slope given to us for the line, right? So that is to say, we'll cross 6 to 1 with the slope of the line, which is 2 minus 1 minus 2. So that becomes the normal. Cross product gives you the normal. Use the method which is known to you to find the cross product. So what I will do here is, I'll write these in arranged fashion: 2, 1, 6, 2, and this starting with the center value, moving right till minus 1, correct? So we have to do the difference of this minus that, correct? So we get the value of this as 2 times minus 2 is minus 4. So that cross product is equal to minus 4 minus this, which is becomes positive. Then we'll do 1 times 2, which is 2. Take away 6 times minus 2, so that makes it positive 12. Then 6 times minus 1 is minus 6. Take away 2 times 2, which is 4. So that becomes the normal vector, right? Now, so that gives you minus 3, 14, and minus 10. Now we can easily find the distance knowing the cross product, which is actually the normal. Now in this case, the distance is given by the formula absolute value of this cross product PQ cross M over magnitude of M. We are actually interested in only the unit vector. Perfect. Now, so the magnitude is square root of minus 3 square plus 14 square plus minus 10 square divided by magnitude of M, which is square root of 2 square plus minus 1 square plus minus 2 square. That gives you the required answer. So let's find this out. So we have square root of, in the numerator, 3 square, all become positive, right? Plus 14 square plus 10 square, bracket close, equals to, divided by square root of 2 square plus 1 plus 2 square, bracket close, equals to. So we get this answer as equal to 5.82. Well, at times you may be required to find the exact answer, so you could do the calculations for exact answer also. But I hope you understand and appreciate how to find the distance from a point line when line equation is given in Cartesian form. So idea here is step number 1, you need to find normal vector. I should say unit normal vector, right? So let me write unit normal vector. Is it okay? So that helps you to find the distance. So I hope this exercise is useful. Feel free to write your comments and share your views. If you like and subscribe my videos, that'd be great. Thanks for watching and all the best.